This is number 25 in section 9.2, and we are going to evaluate the limit as x approaches infinity of 3 over x plus 1. So to do this algebraically, we're going to take the function 3 over x plus 1, and then we're going to divide each term by the highest power of x. And the only power of x, the only x that we have in here is just an x, so that's just a power of 1. So we're going to divide each of those by x. And that gives us 3 over x over x plus 1 over x. And as it is there, it just looks really yucky because you have fractions in the numerator and then you have fractions in the denominator, and it just looks like a big mess. But for the purpose of finding limits at infinity or a negative infinity, when you have an infinity, it's a very large number, or in this case, we're approaching an infinitely large number. So if you were to plug in values at x that continually got bigger, or in the case of negative infinity, smaller, then you would notice that it just gets closer and closer and closer to 0. So if we had 3 over 1, then it would be 3. And if we had 3 over 2, it would be like 1.5. If we had 3 over 3, it would be 1. And then 3 over 4 would be 3/4 or 0.75, and then so on and so on and so on. The number, you can see that the number keeps getting smaller, but it never actually gets to 0. But it approaches 0. So for the purposes of finding the limit as x approaches infinity, when we have 3 over x or 1 over x or anything that's over x or over x squared, those just drop out to 0. So then what we end up with is we have 0 over, and then x over x is just 1 because anything over itself is just 1. So we have 0 over 1 plus 0, which gives us 0 over 1, and then that just gives us 0. So then we're asked about a horizontal asymptote, and yes, we have one, and it's at y equals 0. And a little tip is when you're doing your homeworks, always write it as an equation with the y and the equals sign. Don't just put the number. It'll get marked wrong. So we have a horizontal asymptote at y equals 0 because if the limit as x approaches 0 of a function equals b, where b is a constant, then y equals b is the horizontal asymptote. And don't you just love all of this math language? So put simply, when you take your limit to infinity and you get a constant, not just there's no x's or anything else, 0 is what we got. 0 is a constant, so y equals 0 is our horizontal asymptote. So I'm going to be putting this video in my playlist for the section 9.2 and a bunch of materials. And I also put in some other videos from some YouTubers who are explaining things well. Nancy Pye has some videos on limits to infinity and horizontal asymptotes where she has a way that she explains where you can tell by the powers of x in the numerator and the denominator what your horizontal asymptote or what your limit to infinity will be quickly, like a more quick way. Just watch them carefully and skip over the parts where she goes over trig functions because we don't really do them in this class. So check out those videos, but also understand why this happens, because this infinitely large number that it keeps getting larger and larger and larger. It's like a moving dynamic number, and it just keeps going, but it never gets to 0. So I graphed this function for us, and you can see the horizontal asymptote here at the y equals 0. So the function approaches the 0, but it never gets to 0. So that's why we have our horizontal asymptote at y equals 0. We also have a vertical asymptote here, and that's coming from the denominator because this function would be undefined at x equals -1 because it would make the denominator 0, which we get to in another unit, but you can see that it's kind of a preview. So our horizontal asymptotes are what we're asked for in this problem. And I'm just having you notice we also have a vertical asymptote. Okay,